origin of the universe was a mystery to man for thousands of years. Even before the first civilizations arose, people wondered why the universe existed. During the Renaissance and the Enlightenment, scientists realized that the world was governed by natural laws. Although some of the theories proposed were labeled as heresy, many of them were eventually accepted and paved the road for future scientific discoveries. As Copernicus, Galileo, and Newton established the foundations of modern science, the idea that the universe had always existed and did not have a beginning became a more commonly accepted belief. In the 20th century, however, scientific advances led to the opposite conclusion, that the universe did, in fact, have a beginning. This was a major turning point in our scientific understanding.
Sun shines, Nelly, when the clouds go drifting.
In 1905, an obscure patent clerk named Albert Einstein began to develop theories that were destined to alter our scientific understanding of reality. In 1919, he published the general theory of relativity, which showed that space and time could be distorted by gravity. Shortly afterwards, a Dutch mathematician named William de Sitter announced that Einstein's theories supported the concept of an expanding universe. Einstein was appalled. He believed that the universe was static, did not change in size, and had existed in this state forever. He told de Sitter, "The circumstances of an expanding universe irritates me," and modified his equations to avoid this inconvenient conclusion. De Sitter's work went largely unnoticed until 1927, when a Belgian priest named Georges Lemaitre proposed an expansionist theory based on his calculations. In this theory, Lemaitre proposed that not only was the universe expanding, but it had begun to exist and to expand at a distinct point in time in the past. The theory was greeted with great disdain by the scientific community. Einstein told Lemaitre, "Your calculations are correct, but your physics is atrocious."
No one to talk with, all by myself.
It was an American astronomer named Edwin Hubble who proved that the universe is indeed expanding. Hubble was studying star spectra with a 100-inch telescope at the Mount Wilson Observatory in California when he learned about the work of an astronomer in Arizona named V.M. Slipher. Slipher had observed that other galaxies were constantly in motion. Hubble wondered whether this motion could be proof of the expanding universe suggested by Einstein's theory of relativity. He determined to find out. Because galaxies are so distant, it is difficult to measure their velocities accurately. Hubble accomplished this by studying their Doppler shifts. Doppler shift is an everyday phenomenon that occurs when sound waves from a moving object change in frequency.
But the thing is, light's also a wave. And light also has the speed of light. And when it's traveling away from you, the wave elongates, and that makes it look redder. And that's what's called redshift.
In 1929, Hubble was able to calculate the redshifts of many galaxies, and he discovered an intriguing pattern, later called Hubble's law. The more distant, dimmer galaxies had greater redshifts, which meant that they were moving away from us at greater speeds.
He realized that most of the galaxies around us are actually going away from us, and the further they are, the faster they are moving. And that observation was the first evidence that the universe is expanding.
A loaf of raisin bread is a good illustration. As the bread rises, the raisins move away from each other. The farther apart the raisins are, the faster they move. In the same way, as the universe expands, galaxies that are farther apart move faster away from each other. Hubble's discovery shook the scientific world. Einstein traveled with his wife Elsa halfway around the world, from Berlin to Pasadena, to observe Hubble's results.
Now he's going to the Institute of Technology in Pasadena to work with other distinguished scientists. There his theory will be thoroughly discussed and analyzed, and if it is what he says it is, why then everything will be all right, won't it?
When Elsa saw the huge telescope and learned how the astronomers used it to determine the structure of the universe, she remarked, "Well, well, my husband does that on the back of an old envelope." Einstein, meanwhile, looked through Hubble's telescope, studied his plots of star spectra, and examined his data. At last he reluctantly concluded, the new observations by Hubble concerning the redshift of light in distant nebulae make it appear likely that the general structure of the universe is not static. Many scientists, however, refused to accept this conclusion. The Nobel Prize-winning chemist Walter Nernst announced, to deny the infinite duration of time would be to betray the very foundations of science. The British astronomer Fred Hoyle mocked the idea of a beginning by calling it the Big Bang, as though it were simply a firecracker going off. As an alternative, in 1948, he devised the steady-state theory. This theory proposed that matter is being created continually as the universe expands in order to maintain a constant density and appearance. But it had a problem. There was absolutely no evidence that matter is being created in this manner. Most scientists accepted it nonetheless. In 1961, Arno Penzias and Robert Wilson were engineers at Bell Labs in New Jersey. They were building a large radio antenna for satellite communications experiments with microwaves. As they began to calibrate the instrument, they detected an unexpected amount of static interference. At first they believed it was caused by pigeons nesting in the antenna. After removing all traces of the birds and their droppings, which Penzias delicately described as a white dielectric material, they discovered that the annoying static was still present. No matter what they attempted, they could not get rid of it. Static seemed to come from everywhere, no matter what time of day or night. Meanwhile, a young cosmologist named P.J. Peebles gave a lecture at Princeton University in which he predicted that shortly after the Big Bang, the universe had been filled with an intense glow of radiation. By this time, Penzias and Wilson had realized that the static in their antenna was actually coming from outer space. They contacted Peebles and his colleagues, who concluded that the signals were microwave radiation left over from the Big Bang. Because the steady-state theorists could not provide any explanation for this radiation, scientists realized with excitement that the Big Bang had to be correct. In 1978, Penzias and Wilson were awarded the Nobel Prize for this astounding discovery.
Sharing the 1978 Nobel Prize for Physics are Arno A. Penzias and Robert W. Wilson of Bell Laboratories.
Stephen Hawking called the discovery of cosmic microwave background radiation the final nail in the coffin of the steady-state theory. With the use of satellites, physicists like John Mather are studying this radiation to learn more about the Big Bang.
My idea was, well, we should have done that measurement in outer space. So I was in a position to suggest this possibility, so that became the Cosmic Background Explorer Satellite, or COBE. And so 15 years after we had the idea, it was launched into space by NASA here at Goddard Space Flight Center. We had also built an apparatus to make a map of this cosmic background radiation. So we made a map which we portrayed as a colored oval with pink and blue blobs on it. And we published this. It came out on the front page of Physics Today, and it was picked up by the news media all around the world also. The phone rang incessantly for days. And Stephen Hawking, who's the very famous relativity theorist, said that it was the most important scientific discovery of the century, if not of all time.
This discovery of the century was a historical turning point because it showed the ability of science to draw conclusions despite opposition from the field's most prominent leaders, like Albert Einstein. Not only did it lead to further discoveries such as dark matter and black holes, it answered a fundamental philosophical question that humanity had wrestled with for centuries. As Stephen Hawking writes, "We yearn to know why we are here and where we came from. Humanity's deepest desire for knowledge is justification enough for our continuing quest. There is a point in the past when there was nothing, no matter, space, energy, or even time. And then the universe began to exist.